Hello and welcome. I see one person here, and that's good enough for me. And we're going to start a new series today. So if you're watching, however you're watching this, not live, but somewhere else, like on YouTube, welcome. Just a quick intro. My name is John Reed. I run the website qualitycoding.org, and I am a technical agile coach at Industrial Logic. And the first and last series of live coding I did was doing test-driven development in Swift. And we concluded that. So the question was, what are we going to start today? And the answer that I came up with out of need, seems like following one's need is a good thing, a good place to start, is to convert a project from Objective-C to Swift. But as always, you are welcome to interrupt me with random questions. If I don't feel like answering your random question, I'll let you know, but that's very rare. I don't think I've ever said that, actually. Random weird questions about whatever, about tooling, about coding, about career, whatever. Let's have fun and let's do this together. And as always, I really appreciate your interaction. For those of you who are live with me, you know, if you've seen me before, you know I'm not the best coder. I just have some good habits, I think. So I lean on you for good coding. I bring the good habits. Together, hopefully we make good magic happen. So let me see if my overhead is still alive. It is not. Oh, yes, it is. But that's the wrong one. There, the big one. I'm going to need to improve my setup here. But let me just talk briefly about sort of a basic strategy for converting Objective-C to Swift. Step one, let's make sure we're here, is like you gotta have tests. Step one. Hey, Garbob, welcome. On the ground floor. Step one is to have tests. But sort of step 1A is convert those tests to Swift. Why is that? It just makes life easier. Basically, the tests are kind of like their own home for the future, and you want the maintenance folks out there all ready to go, already operating in the new language. This may mean some changes and sacrifices for things that are not available in Objective-C. I mean, in Swift. Things that testing tools that you used to use, like my own OC Hamcrest and OC Makito, no longer very helpful. They continue to work for Objective-C code. That's great. But they won't be a good home for Swift code. And then the next thing is to sort of figure out your dependency graph or your dependency tree. This is really important because in any code you've got like stuff that depends on other stuff. It depends on other stuff, you know, some kind of tree structure you have in your code, as far as like you might have everything sort of dependent on a piece of like something really common. So this is common shared code. And out here at the leaves is interesting. Why do I say this? Because a mistake I've seen is to say, okay, here's the common code. Let's move that over. Let's make it Swift code that works, you know, that continues to work for Objective-C by marking it as such. And so then you end up with Objective-C code depending on Swift code. If you see what I mean, if we convert this right here, if we convert that common, really widely used bit and say, wow, we've made so much progress by converting the most important, the most commonly used stuff to Swift, you've just shot yourself in the foot, because then you end up with that's Swift, but this is Objective-C code depending on Swift. And then you get Swift code depending on Objective-C code, and the build system, your build feedback is just going to fall down. You're going to make an incremental change, and it's going to rebuild the world. And you're like, but I didn't change that much. Yeah, but because of this. So the answer is, don't start there. Start at the leaves. Find the things that nothing else depends on. It can depend on other things, but nothing is depending on it. Those are our targets. And we start working at the leaves and we work backwards. And there, in a few minutes, you've got your sort of the ground rules of Objective-C to Swift conversion. All right? I should probably take a picture of this and for posterity, since I use my whiteboard all the time for other things. Okay. With that, where shall we go? I would like to go to a particular project. At first, I was thinking of an app that I have. Hey, Javier, come on in. And a really old Objective-C app that I haven't touched in years. And I thought that could be good. But I have this other thing. It's a testing library called View Controller Presentation Spy. If you haven't seen this before, it is a really handy way to test alerts, view controllers that are presented, and view controllers that are dismissed. And I wrote this originally in Objective-C. And then I added, it continued to work in Swift, but it wasn't very nice because it wasn't very Swifty. And then as I got better at Swift, I'm like, oh, this can be improved. And I added a bit of Swift to it. If we look in the source here, actually, that's not going to help us. Let me just to show you, in case you're not familiar with this library, here is some nice Swift code for saying, okay, let's make an alert verifier, call the system under test and have it show an alert, and then say, verify all these things, the title, the message, was it animated? What was the presenting view controller? What are the actions? And you can then also trigger those actions. It's grosser in Objective-C. And maybe I can find ways to improve this. But here in Objective-C, the old way I did it was, a bunch of properties that you can verify. So let's put that away. And let me go to SPY. Yeah. I'm using fish shell, and I'm using this nice thing somebody wrote in a different shell called Z or Z. And it's like, remember, it's almost like it creates dynamic keywords for folders or directories so you can jump there. So inside of here, it might be better if I show this in the Finder. So inside of here, we've got, it's kind of, I want to show you the structure a little bit because it's a little weird. This is the source code, and it has no tests to speak of, not inside of there. Outside here, there's a Swift sample and an Objective-C sample, and these are two apps, and those have some tests. Both as examples and as some verifying some fiddly details about the view controller spies. So it started with Objective-C tests, but then it became Swift tests. So I already have tests written in Swift. So in terms of the step 1, have tests, yes. Convert them to Swift. I basically already have that. So let's go into the Swift project and just here you see there's a sample app with a bunch of stuff, and here's the framework in question. Let me run the tests. Oh, and going off of your poll on Twitter, I changed. Your eyes aren't blinded anymore. I originally started with the color theme I like to use, which is called Darkula. It's the default app code theme, but the contrast isn't very good. So then I switched to light, but as I was thinking about it, and the reason for my poll was that I learned that there are good plugins. AppCode has plugins for themes. And so I installed well, if I look for like theme, I seem to be beach balling a lot right now. I can't wait for my new computer. So there are a whole lot of themes, and you can just download them and install them and try them. I got one that is designed to be similar to the Xcode Dark theme, and so that seemed like a good thing to roll with. All right, tests are still instantiating. I bet it, sorry about that. I didn't fire up the simulator in advance. There it goes. A little slow. It'll get going. That took a long time. Second run should be much faster. Let's see. Come on. Wow, it's still really slow to me. 2.5 seconds feels like an eternity. Well, my memory is kind of not great and stuff. It's good enough to work with for now. All right, so I've got tests for various things: the alert verifier, the dismissal verifier, the presentation verifier, and then I have a couple of like example tests for testing alerts and presentation. So let's now find those leaves. What is inside of here? And you're joining me now, and I don't know quite what I'm doing because I don't practice these things. Live code. All right, so you see there are a few Swift things. Oh, interesting. I made the verifiers themselves Swift. And that was so that I could get the get that better Swifty behavior. But the guts are still Objective-C. What do we got in here? Let's see if we can't figure this out. Actually, I think I'm going to need that whiteboard. So I don't want to lose it. So I'm going to take a photo just for my sake here. That's good. All right. And I did that so that I can use the board to try to find the leaves and stuff. Because we've got this. What's this? This is an umbrella header. All right, let me start drawing these out. Uh-oh, my camera has gone dead. I am sorry. You're not going to be able to see me draw. Oh well. It happens. Let's find out what we have. I've got extensions on NSObject. Alert action, alert controller, UI view controller. Let's see what those import. It looks like they probably, being good extensions, this is going to be the easiest conversion of any app. Oh, was the tree you drew? Yeah, it was a dependency tree. I'm reminded of an old tool I used to use a lot. Let me see if I can find it. To make the dependency graph. Was it? Was it this one? Was it Paul's? I don't remember. I do not remember what I used to use. Do I even still have it? Let me go up to the source. You know, I probably don't have that tool anymore. But I don't think it's going to be really necessary, not for this code, because it's so small and we have all of these things that are just extensions. And I think I should be able to start converting the extensions. Oh, wait, I shouldn't look just at the headers. I forgot. I need to look in here and see. So this imports, well, it imports its own header. And as you can see, it does method swizzling. This one. I think I'm really lucky. Well, I'll have to come back to this. I'm not sure how this umbrella header is going to go. But let's take one. I think I am mostly at a super shallow tree of leaves, mostly leaves. So let's start at a leaf and start with the alert controller, the heart of this project. What have we got? It does swizzling. It's not very long, but it's got some Objective-C code. I'm sorry, some iOS code, iOS specific code mixed in there. Because you can use this. Why did I write iOS specific code? I mean, why did I have to have that? I think it's because it is actually... Yes, I'd forgotten. I added tvOS support. And not everything is available on tvOS. All right. Well, here we go. What does the swizzling call? Replace instance method with method. Method exchange implementations. Oh, that is the swizzling code. All right. Wait, where did I end up? I think I ended up somewhere else. NSObject. Again, I don't want to convert something that I depend on. I want to convert here. All right, let's go. Let's roll. And I'm not sure what I'm doing, so let's make a new branch just in case. Just call it whip, work in progress. Let's roll. UI alert controller. Let's create a new Swift file called UI alert controller plus QCO mock. QCO mock. Why is it QCO? And the answer is in Objective-C, there are no namespaces. Everything is flat. And so if you want to create your own exposed name, you really ought to prefix it. I don't know that I need this, but I'm going to keep it the same naming convention. I might change it later. We'll see. And I'm going to extend, well, this is going to import UIKit because I want to extend UI alert controller. There we go. That seems like enough of a step. I'm a little scared to use TCR, test and commit and revert, but maybe that's exactly what I need. You see me working in a super small step right now because I've been so trained by TCR. But I'm a little afraid of doing this for something so big where I need to basically lay down a bunch of stuff. What could I do? You know what I can do is I can expose a different, instead of exposing these. So I want to, yeah, Garbob. Do it! I can, instead of thinking in parallel change, you're watching live as John Reed puzzles through a problem. When you're doing a parallel change refactoring, I can't draw it. You lay down, you've got the old thing, you keep the old thing there. You lay down a new thing next to it that is exactly you want to build it up to be the same, and then you switch it over and then you get rid of the old thing. All right, let's do it. Here we go, TCR. In fact, forget this branch business. Let's go on main. Let's set up not change size watchdog, but test and commit or revert. Oh no, I need to remember this. Shoot. Was this it? I'm not going to change any test code yet. So maybe I don't even need to worry about this yet. All right, let's go. Here we go. I've got the new file sitting out here. Let's do it. There, my tests are getting faster. So that should have done. That is not what I wanted. Where is the change? Enabled on past test, commit. Use the commit message from the last commit. I do want to notify and revert. Don't revert test, doesn't work. I'm just getting nervous here. I like the soft. The soft test, but why didn't it commit? I'm not sure. Let's see if I can. Something's wrong. Something be wrong with my TCR. Enabled unpassing. I am not sure why. Not being sure, I will reset hard head. I'm not expecting anything to change right now, but let's me try again from the same safe starting point. Oh, you know, I think I know why. I bet it is the structure of, hey, Mudshark, I'm trying to enable TCR right now, and it's not working, and I think it is because of the structure of my project. Darn it. I have a weird project of unusual shape. Unusual because my source code is in here, but that's not the project we're in. We're in a project called Swift Sample, and TCR is not picking up that I really want to monitor changes in here. Darn it. Well, You know, fine. I'll turn it off and we'll pretend. I'm going to continue to move in small steps. So here we are. Let's start over. Swift file. It's going to be our UI alert controller plus QCO mock. Let's make it a little more interesting than that. This should build. I don't need to run tests. I'm doing it by hand. Bummer. That's just because I have a weirdo project. It compiles. So do it by hand. Oh no. My GPG signing is off. GPG, I need to kill the agent. And I think now I can try again. Let's do that. There, that worked. That's something I learned the hard way. I do like signed commits, but sometimes the agent goes weird, and then when Git is saying, okay, and we need to have this agent sign the commit, and the agent is like, then you need to go in and kill it, and it will be happy. All right, let's bring this up side by side. Let us split this right, and on the left side, let us find the alert controller, and here's its quick little interface, mock swizzle. Well, that won't do, obviously. This is going to be a static func. I'm going to call it mock2 swizzle. And I do need this to be called from Objective-C. So where does that decoration go? Does it go there? Or does it go? Looks like it goes there. All right. So this is just beginning an empty extension that does nothing. Again, nothing's calling this. As long as this builds, I'm okay. Our interfaces, also used as extensions in Objective-C. In Objective-C, what you're seeing, this is the interface is basically the public signatures. That's what you get. That's what you're seeing here is the public signature of this method. The fact that it's plus and not minus is what distinguishes it between being a class method and an instance method. Technically, I suppose this should be, if I'm going to be completely the same, I'll start working small steps, right? I'm going to make this a class func rather than a static func. So that's the signature. Now we can go to the guts. And let's just start building this out. Actually, let me commit this. You know what? I'm happy to commit what I have here in an amend. So I'm going to do that. All right. And now it looks like maybe I should put top and bottom because of how big I have things so that it's very visible for folks no matter what kind of device you're watching on. Let me split this top bottom. Say split down. There. That's a little better, isn't it? All right, so it looks like Mock Swizzle does two things. It replaces one method, and for iOS, it also replaces another method. But we can start with the one. And this is kind of a funny thing, but I like to sort of copy and paste, and then we'll figure it out. Oh, shoot. No, this is, I'm getting confused as far as my dependencies. It's like, oh no, this is calling something else. Shouldn't it, shouldn't I start at the deeper thing? And then I think, no. The dependency graph says start at the leaves, not at the commonly used thing. So what I wonder is if I can call this from Swift if it's properly exposed. I probably can. So I should be able, maybe, how do I get there? This is inside of NS object. All right, so it needs to be self. So can I call this thing at all? Okay, first hurdle. I want to call Objective-C from my new Swift thing. But that seems backwards. No, it doesn't. No, it doesn't. Swift can call Objective-C. See, the dependency graph thing. This is why teams are like, oh, I should call. It feels so natural and so like the right way to do things to convert the thing you depend on. It's like, no, you want to keep it so that the direction of dependency is always Swift can call Objective-C, but Objective-C you do not want to call Swift. So I just need to figure out how do I expose this to Swift? And I thought that would be easy, but okay. It's been a long time since I've done this, so clearly I need to look it up, unless one of you can tell me. Objective-C exposed to Swift. Oh, that's right. I need a bridging header. I need to create a bridging header. Yep. Bing, bing, bing. All right, let's see if we can remember how to do this. The bridging header is going to live out here. What do you normally call bridging headers? I mean, in terms of their naming. I thought that they usually had some weird naming. Objective-C looks weird, Javier, but it's a lot of fun. But I'm going to try to finish this thought before I talk about that. I thought there was some funky naming. So it's a Objective-C bridging header name. Usually added when I add a Swift file. Unfortunately, I already had a Swift file in there. Doesn't that mean I already have a bridging header in there? Right. How is this? Let's take the alert verifier. How is it calling anything? Alert verifier swizzle mocks. There it's calling this, right? There's the one we want to change. So let's see where this is, maybe where it's to look for UI alert controller. Yeah, that's the thing. Thank you. Look in the whole project. Don't look in Swift files. I'm just wondering, how does this work? How is it presently working if I don't have a bridging header? These are mysteries. So this, it finds this. Oh, I need to address the class. The class is NSObject. Will it be there? No. Puzzlements. But for now, I'm gonna slap this in as sort of the ultimate expression of parallel change, that this temporarily calls that, and so something out, whatever calls mock swizzle could start calling mock 2 swizzle. I am honestly a little confused right now. As to how, if I do not have a bridging header, is this is this working? Here's everything I have. Maybe I need to look in, let me pull up Xcode. It's just easier to deal with project changes. Because maybe I'm already, like, I'm repurposing the framework header or something like that. Right, so if we go in here and look for extern, no, that's yeah, you're thinking in C++ land. Objective-C bridging header. See, it's not there. I do not have one. So if I don't have one, how is this working at all? And can I call NSObject anything? QC, no. But I can call UI alert QCO. Okay. I don't know yet. But let's find. I should be able to find uses of this one. That's it. Something's wrong with find usages. Because we know that ain't so. Ah, darn it. I'm being baffled. It must be internally exposed, but not externally. Okay, come back, Xcode. I'm sorry. I kicked you out too soon. Let me check the headers and see where they are. And maybe I need to expose some things a bit. So if we're looking at like this header, it is declared as public. But I suspect this one is not. This one is a project header. Maybe, just maybe, if I change this to be public and say, you know what, expose stuff. And maybe this is a good lesson. Well, let's see. Let's see if we get lucky. All right. So I don't know. Can I call NSObject QC? Come on. What if I rebuild you? No, darn it. Back to Xcode. Making it public is probably not a bad move, though. Let me just check them all. Okay, so that was the only header that was concealed. Exposing it seems like a good move. Let me commit this change here. Yeah, it's some sort of gobbledygook inside of here. And I'm a little scared, so I'm going to run tests. All right. So this is an environment change. Make baby steps. All right, still the mystery. We've got this. Really not sure. Let's find that alert verifier, which calls alert controller mock swizzle. And let's see if I can't call mock to swizzle. This should still pass. Do I want to switch it yet, though? I'm not sure that I want to switch it yet, but maybe I do. Let's go for it. It's harmless. So far. No, not yet. My gut says, leave it alone. I really want to populate the contents of this first, rather than have it just be like a redirect. Okay. So now I'm stuck. We are, and I'm nearly at time. Our mystery is, how is stuff being exposed? Like, how is this exposed? UI alert controller, QCO mock, inside the directory. Is it because it's out here? At the framework level, let's try. So now that I've made the NSObject extension public, I can probably, well, let's find out. I do that, right? This should build okay. But my question is, now can I? There it is. Okay. So it looks like it wasn't in a bridging header, because this is not, it looks like in the framework header, which is always written in Objective-C if you still have these things for frameworks. And every time you make a new framework and it makes a .h file, someone asked me the other day, it's like, why is this here? You know, all it has is like these things in it by default. But it looks like if you put, if you expose it publicly, Not even sure if that step is necessary, but if you put a header in here, then when something else imports that framework, it's going to pick up anything in here. So this is a good step. Woo, we finally broke through. Let me double check tests. I don't remember when I ran them. All right, another environment change. Add extension to framework header. Learning. All right. I think I'm finally set up for some success. Bit awkward start. Hey, it's how things start. But I think so as not to continue to stick to my pattern, which I kind of like, and I don't know, it works for me to keep my blocks of live coding to 1 hour. It does stretch out the projects themselves immensely, week over week, but I don't want to put up huge things that people who are curious would look at and be put off by us and say, wow, I don't want to watch this guy code for 3 hours. And I've got other things I want to do today. So thank you for coming by. Why is that not showing? I don't know. My OBS sort of all over the map today. So is the bridging header used to add those imports, perhaps? It looks like we're hitting some sort of weird thing where it's like, when you're in a framework and you're exposing some things inside the framework, it automatically does bridging for you. I bet if I created a bridging header explicitly and added it, that might have solved things, but I was just puzzled by like, how did this work at all? So, Monday is Martin Luther King Jr. Day for me. I plan to stream. I'll be taking the day off. So hopefully see you in a couple days if you can make it. And I am out. Thank you for joining. Oh, as always, if you're watching this on YouTube, do all the things. Like, subscribe, bell, blah, blah, blah. See you later.